I welcome you all for today's class on projection of solids, and the problem which I am going to explain is on square pyramid, and it is a beta angle problem. Okay, so the problem is like this: a square pyramid 35 mm sides of base and 60 mm axis length rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degree. So to solve this problem, so first I will consider the conditions. So what is the condition? Identify the resting plane and how it is resting. Okay, so for that, identify the resting plane. So it is resting on HP plane. So initially we have to place the square pyramid on HP plane. Okay, next, how it is resting? It is resting on one of its slant triangular faces. When the condition is slant triangular faces, make sure that the edge resting, edge representation has to be done, not the corner representation, corner resting condition. So this is how initially the square base has to be represented, and the apex point has to be marked. With respect to apex point, all the corner points has to be joined, and the naming A, B, C, D will represent the base of a square pyramid, and O point represent the apex point, and O1 is the center point of the base of the square. Okay, next we have to project the lines upward up to the xy line. From O1 dash I will draw a line of 60 mm, because he has given the axis length of 60 mm. Okay, 60 mm length has to be drawn from the O dash. The line has to be drawn to the corner points of both the sides, and the complete view of a front view will look like this. That is, it will look like a one of the triangular face will be looking. Okay, so the naming condition is the B dash is visible, because when I see from this direction the B point is visible. That is why B dash has been represented, whereas C is hidden. So the C dash will be represented in bracket. Similarly, A dash is visible, D dash will be represented in the bracket. Then what is the next condition? We have to tilt the this view at some particular angle. If it was a inclination with respect to HP at some angle, that is the previous problem what we did, the base was being inclined at some angle, right? The axis inclination with respect to HP was at some angle. That is why with respect to the base we used to tilt like this. But in this condition he is saying that whole face, triangular face, is been resting on HP plane, to rest with slant surface on HP. So that is why the pyramid is been totally tilted in such a way that the face, one of the triangular face, is on HP plane. So that is why the resting of this view will be completely made on XY line. That is, A dash, D dash and O dash will form the triangular face that will be completely shown on XY line. Okay, so this line will be made to fall on the XY line, and remaining step is what? To complete the lines and get this view. The naming will remain the same, and the projection lines will be drawn downwards, and make sure that the outer line will be of visible line. Right. So now to identify the hidden line. How to identify the hidden line? A dash and D dash is one of the uh, points where it is far away from the observer, right? So whatever the line which is been joining with, from the A and D will be of hidden line. So you can see here A is connected to O, so that is why it is shown in hidden line, and D is also connected to O, that is shown in hidden line, and D and A is connected but it is not shown in hidden line because it forms a outer line. That is why in the initially I told that the outer line should be represented by visible line, and the farthest points is A dash and D dash. So from that, whatever the line that has been connected should be represented in hidden line. Okay, next, what is the next condition? The inclination with respect to another angle. What is the another plane? That plane is VP plane. So the axis, when the axis is inclined to VP at 45 degree. Okay, so he's speaking with respect to the axis. So you can see here the length of the axis is how much? 60 mm. Okay, so but you can see here when it is been tilted on the HP plane, the length of the axis will be reduced, right? So this is the apparent length and this is the true length. So when the apparent length and true length is coming into picture of with respect to the axis length, so we come across a beta angle problem. Okay, so the axis length is 57.6 mm, whereas the true length is 60 mm. So for that condition, what we have to do, initially we have to draw a 45-degree line because the axis is inclined to VP at 45-degree line, right? So 45-degree line has to be drawn. Next, considering the point O, we have to cut an arc of original length of axis, 60 mm has to be cut. Next, taking this O1 as the reference, we have to cut an arc to the locus line which is been drawn for the 60 mm length. So that we will get O1 line. And remaining step is what we have to make sure that O1 will lie on this O1 line. Okay, so the line will be extended so that thereby the beta angle will be obtained, and remaining lines will be drawn upward to get the final front view of a square pyramid. Okay, so to understand this step, I will explain it in how to draw manually or in software. Now I will explain how to draw a square pyramid of beta angle problem in SolidEdge software. Initially, we have to select a line and draw a XY line and name it as X and Y. Because we are following first angle projection, VP plane will be above XY line, HP plane will be below XY line. And we have to represent the base of a square pyramid. Where we have to represent on HP plane because it is resting on HP, right? So that is why I will select the rectangle by center option and I will draw a side of 35 by 35. Yes. Next, we have to draw a apex. From the apex point, we have to draw or join the corner points, right? So apex point will be at a height of 60 mm from the base of the square pyramid. So from the apex point, I will join all the corner points. Yes, I have joined the corner points, and all this is will be seen, right? When it is being seen from the top direction, all the corner points and the slant edges which is been joining from apex point will be seen. That is why all the lines will be made visible. Okay, next, naming. I will name this point as A, B, C and D, and apex point I will name it as O, and the base of a center point of a square is being represented as O1. Okay, now using a projection line I will project it up to XY line. Next, from this point I have to draw a center line at a height of 60 mm because the axis length is 60 mm, right? So 60 mm has to be taken and should be drawn. So we got the apex point. From the apex point we have to join the corner points. Yes, and we will get this view. So when a square pyramid is being placed on HP plane, then when it is being seen and projected to the front plane, the view that is being obtained will be of a triangular face. This is how it will be looking, and the length, the axis length has to be shown, that is 60 mm. Yes, right. So naming, coming to the naming, the B corner point is visible. When I see from this direction, B is visible, whereas C is hidden. Similarly, A is visible, D is hidden. So what I do, I will name this point as B dash in the bracket C dash. And this point, it is A dash in the bracket D dash. Okay. Yes. Now remaining is what? Apex point. Apex point has to be represented. So this point will become O dash and this point will become O1 dash. Okay. So what is the second condition? The square pyramid is resting on one of its slant triangular faces. So which is the slant triangular faces? A dash, D dash and O dash will form a triangular faces. Okay, because we have taken this AD as the reference edge. Okay, so with respect to this becomes the slant triangular faces, and this will be tilted in such a way that it will be resting on HP plane. So that is why what we do, we select whole thing, and we will use move option and make sure that it is placed on XY line. We have to switch on the copy option. Copy option, move option has to be selected, copy option has to be on, and we have to place it. Yes. Now what we have to do, we have to rotate till this line is lying on the XY line, and make sure that the copy option is off. Yes. Now it has been tilted in such a way that the triangular face, that is A dash, D dash and O dash, right, it is on the HP plane. It is resting on HP plane. Okay. Now I will just, for a convenience, I will move little bit nearer to the first position so that the space will be available for me to draw for the final positions, right. So next I will use the projection lines. So here you have D dash and A dash, right? So D dash and D intersection. Next A dash and A. Yes. D dash we have obtained. Remaining is A and A dash intersection point. Yes. Next here we have B dash and C dash, right? So first C dash. C dash, next B dash and B intersection. Yes. Next from O dash to O intersection. Next O1 dash to O1 dash to O. So now I will just mark the points. So the point is what? This is A and this is point number D. This is point D and this is point C and this is point B and this is O, right? So not to get confused, right? For that reason I have just marked the naming. Okay, now I inform you that when I see from this direction, which is the farthest edge, A dash and D dash is the farthest edge which is hidden, which is not been seen on the HP plane. So for that, whatever the line which has been connected with respect to A dash and D dash will be represented by hidden line. So here is hidden line is here. From A dash to O dash, hidden line. So from D dash to O dash, that will be hidden line. Next, whatever the line which has been connected with respect to their lines, with respect to their points, will be shown by visible line. So visible line I will select. So O is connected to C, right? O is connected to C. Next C is connected to D. Next D is connected to A. Next A is connected to B. Next B is connected to O, right? Next C is connected to B. Yes. This is how the representation has to be made. That is, the representation of hidden line is very much important because the farthest edge is A dash and D dash. So whatever the line that is being connected with respect to that will be in hidden line. So remaining is what? Representation of a center line. Center line, right? From O to O1. Yes. And I will name it as O1. O1. Okay. So we have completed the two positions. So remaining is what? Last inclination angle is with respect to VP plane. So the pyramid, when the axis is inclined to VP at 45 degree. So is want to incline the axis with respect to VP plane at 45 degrees. So where is the axis? Axis is this one, right? This is the true length of the axis line. But when it is being tilted with respect to HP plane, what happens to the axis length? It becomes apparent length. So you can see here the length of this axis line is reduced. It is 57.6. So because he is asking with respect to the axis line, this problem will become beta angle problem. So for that, what is the first step? What we have to do? We have to draw an angle of 45 degree line, because the inclination angle with respect to VP is 45 degree. So that will be represented in VP plane, right? I mean HP plane. 45 degree minus 45 degree, I will represent it of any length. Yes, of any length, and that should be of projection line thickness. Next, what we have to do in beta angle, initially we have to draw a arc of length 60 mm. The true length, whatever the true length has been given on this 45 degree line, I will take this point as a reference and I will cut an arc of 60 mm. Yes. Now I will draw a locus line. Now I will draw a locus line. Now I will draw a line. A locus line has been drawn. Next step is what? Similarly, I will cut an arc from the same point, whatever the same point I have taken, reference point, from that point itself I will cut an arc of length 57.6. So select this point and cut an arc of 57.6, enter, and it will cut at some particular point. Yes, it is cutting at this particular point. So what I do, I will join it from this point to this point, and I will extend the line. I will extend to the next. The line will be extended. Yes. Now I will check the angle. What is the angle that I have obtained? The angle that I have obtained is 47 degrees. So that is the beta angle. And now what is the step what we have to do now? So the point which we have taken here, it is O1, right? This is O1, O1, and this is O. So this axis line should lie on this beta angle line. So for that, what we have to do, we have to select whole thing. You have to select whole thing. Use a move option button. Select this point O and place it on this point. We have to copy. We have to copy the view. Use copy option. Select the point and highlight on the arc so that we will get the point O and place it. Next, you have to rotate it. Use rotate option. Select the point O and O1 and tilt it in such a way that it should be aligned with this beta angle line. Yes. Have you got it? So this is how it has to be solved. The beta angle problem, this is how it has to be solved. Initially, the initial angle what we have took was 45 degree line, right? 45 degree line which was taken with respect to the true axis length, and next we got the beta angle problem, beta angle, and to that beta angle line we placed this view and we placed it here. Okay, next to represent the final position, so to represent the final position of the front view, what we have to do, we have to project the line upward. Okay, now draw the projection line upward to get the final front view of a square pyramid when it has been inclined with respect to both HP and VP, right? So next what I do, I will draw a projection line from point C. I will extend the line up to C dash. Next from point D, I will extend up to D. Where is D? D is here. Next from point B up to B dash. Next from point A up to A dash. Remaining is what? From point O to O dash. Next O1, O1 to O1 dash. Yes. Next, what I do? I will just mark the lines. Okay, so mark the points. So this point is A dash. This is B dash. This is O1 dash. This is D dash. This is C dash. Yes, I have marked the points and remaining is what? O dash. This is O dash. Okay, I have marked the points, the corner points or the points in which O and O dash has been intersected, right? So now, what we have to do when I see from this direction, which is the farthest point, B. B is the farthest point, right? So whatever the line which has been connected with respect to B, that will be hidden. Or else another step, another condition is what? When I see from this direction, this plane will be visible for me. So what I do initially, I will complete the plane from which is connected to A dash to B dash, B dash to C dash, C dash to D dash, D dash to A dash. This will be visible. It will be visible, right? So I will make it complete visible line. Okay. Now, whatever the line which has been connected with respect to B dash, that will be hidden, right? So what I do, I will select the line hidden, and from B dash it is been connected to O dash, that will be made hidden. So B dash, B is connected to O as well as it has been connected to C and A, but it becomes the outer line, outline, right? So outline will be always be visible line, so only this line will be of hidden line. So remaining line should be represented with visible line. So I will connect from C to O dash. Next from D dash to O dash. Yes. This is how the beta angle problem has to be solved. I think you people have understood how to represent the beta angle problem and finally how it will be represented, right? The final views. This is very important step in beta angle problem, right? So thank you. Thank you.